Today we're going to be talking about some dam issues and resolutions within our world today. And I'm Angie Volcho.
I'm Mackenzie Hennis.
And right now there are about 57,000 dams in the world over 4 stories tall. So it's a very big and relevant issue. To start, we will talk about two of the largest issues with dams and the largest natural interruptions, including fish passage and sediment buildup. And as pictured here, you can see the fish within the dam turbines, and as well as an excessive amount of sediment being released from a dam. And as you can see, these may pose some issues. So the first issue, like I said, is fish passage. And with this, dams make it very hard for fish to migrate throughout the river, leading to fish population decline and some species nearly to extinction. Some fish, although, do make their way up to the river, although it's a very small amount. The dams also cause issues for the fish that attempt to make it through, including getting chopped up by the turbines and knocked out by the amount of water pressure within. The dams also lead to diseases being propagated in the water, in which the fish then develop. There's also a change in the environment, which Mackenzie will talk more about, leading to fish losing their migratory instincts. For example, the Elwha River in Washington had the Glines Canyon dams, which almost wiped out the entire steelhead, trout, and salmon population as pictured. And they said, maybe you could say you could fix it with hatcheries, but actually they tried and they were all inbred, which was a very big issue. And then when the dam was destroyed, which you would think the fish were then thought to thrive, they actually had adapted to the lake environment by that time and lost their migratory instincts, continuing then with the fish population decline. So to fix this problem, some fish ladders have been developed, including the one pictured on the left, which is a vertical slot fish passage, which is essentially a ladder for the fish to swim up, and instead of leaping over obstacles, they created a nice narrow slot on the side so they can swim up it. And if the barrier is too large or the dam wall is too big, this fish ladder would become too long and too excessive. So the fish elevator on the right was made and developed, which basically accumulates a bunch of fish in a collection area and raises them over the barrier to then get freed into the river. And even though these were developed, it didn't create too significant of a change in their migration patterns.
So now I'm going to talk a little bit about sediment buildup behind dams and the environmental effects. So there are a few potential downsides to releasing the sediment buildup downstream, because many dams have been collecting the sediment for almost a century, so they contain toxins, primarily PCBs, dioxides, and heavy metals. These toxins are very expensive to remove, but if they're not properly removed, they can harm the water downstream. Releasing all the sediment buildup all at once can also raise the temperature of the water, which leaves sensitive species at risk of not getting enough oxygen. Although these are expensive and potentially harmful effects, they're all pretty short term and they can be avoided if the appropriate measures are taken during removal. The benefits of natural sediment flow far outweigh the potential downsides. Natural sediment flow creates new habitats, facilitates migrating and spawning areas for all of a river's organisms, and allow access to floodplains and nursery habitats, which you can see on the photo on the right there. In general, riverbeds are a fragile and diverse ecosystem, and many of the organisms require specific types of sediment to thrive, both plants and animals, and restricting natural sediment flow doesn't allow that to happen. One of the solutions many dams have been trying to make is modifying their river management style. So river management is already a crucial part of maintaining dams and waterways that the dams modify, but most river management is focused on water quality and water discharge, but recent efforts have been made to restore sediment flow. Although many dams have been making changes in river management to include sediment regimes, they're incredibly difficult to implement because of the lack of data. Less than 10% of the 23,000 U.S. Geological Survey gauging stations don't have long-term suspended sediment concentration data. Rivers respond very differently to changes with and without the appropriate long-term data, such as magnitude, frequency, duration, time, and rate of change of natural flow. And without this data, sediment regimes can't be properly managed. The goal of the sediment regime is to balance the energy of flow available with the sediment supply, meaning that when the appropriate river flow for sediment transport's available, sediment is allowed to flow freely. But this isn't completely achievable under current conditions, because of human impact on almost every portion of a waterway. There's been very limited success to date using sediment regimes, and the only truly effective way to return sediment flow to a river is by removing dams completely. Dam destruction is a complicated process and very expensive, but many dams are reaching their life expectancy and producing minimal power, so tearing most, if not all, dams will be necessary in the coming decades. There are various factors that make dam removal expensive and complicated. A few we've already talked about, but as an example here is the 200-foot Matilija Dam in California. It was constructed in 1947, and it causes almost all the negative impacts we've already talked about. The dam removal effort has been going on for nearly 2 decades, but the cost of removal is $140 million. So tearing down the Matilija Dam would be one of the largest dam removal projects in California's history, and the removal effort is still going on today, but the cost of the project is the largest obstacle faced here and is the same obstacle faced in many other dam removal projects.
So we're going to look at some dam alternatives with other types of power, including wind turbines and ocean hydropower. So 80% of the dams regulated by the Federal Energy Regulatory Commission produce less than 50 megawatts of power, which is comparable to the power 50,000 homes. Although when compared to other major power plants, this amount is incredibly small. For example, a nuclear power plant produces almost 4,000 megawatts of power. So with this low power output of these dams, this power can be replaced relatively easily with modern renewable energy sources, such as wind turbines and ocean hydropower.
Wind turbines are a great alternative to replace dams with because they use the same existing power lines, so no additional infrastructure needs to be built. One individual onshore wind turbine produces 2.5 to 3 megawatts of power, and one offshore turbine produces around 3.6 megawatts of power. One individual turbine would be used primarily to power a small farm, a house, or other small electrical needs, which is similar to a micro dam, which would be if you dammed a creek. Small dams, which usually dam small rivers, produce less than 10 megawatts of power, and they can be effectively replaced with only 2 or 3 turbines. And although there are negative environmental impacts of using wind turbines, such as the death of birds when they run into the blades, these impacts are far less long-term than the use of dams. So a little bit on how wind turbines work. The shape of the blade is key to optimize the transfer of kinetic energy of the wind to the mechanical power in the generator. There are different airfoil cross-sections which produce lift and cause the blades to rotate. The blades are tilted to align with the relative wind speed, and the blades are twisted because the relative velocity is more inclined at the tip of the blade, and the twist angle aligns the relative velocity vector more ideally. There's also a yawing mechanism and a pitch mechanism that always keep the turbine normal to the wind and at the optimum attack angle.
And as for other hydropower alternatives, we can also harness the power of the ocean rather than the rivers. So on the left, we have pictured a terminator device, and these are usually anchored to the shore, and they sit perpendicular to the direction of the wave and capture its power. And the way it works is basically the water enters into a chamber through a subsurface opening in the terminator, trapping some air above. And then the wave action going up and down causes the piston to move up and down, forcing the air through an opening connected to a turbine to then generate the power. And on the right, we have pictured an attenuator, which are long multi-segmented floating structures, which are lined up parallel with the direction of the waves. So they ride up and down the wave, and the differing heights of the waves along these stretches of segments cause flexing where they connect, which then are connected to hydraulic pumps, where then the power is generated as the waves flow through. And then a transformer is then used to step up the power to line voltage for transmission to shore.
So as you've seen, there's a lot of really negative impacts of dams. And with the recent developments in other alternative sources, dams have become a pretty obsolete form of alternative energy. And so in conclusion, it is time for us to free the rivers.
And save the fish.
Thank you.